Assalamu alaikum. I am Mofit Mojib Haider. I am going to explain word sense and relations between senses. A sense or word sense is a discrete representation of one aspect of the meaning of a word. Loosely following lexicographic tradition, we represent each sense with a superscript. Relations between senses. Synonyms. When two senses of two different words, lemmas, are identical or nearly identical, we say that two senses are synonyms. Synonyms include such pairs as sofa, couch, vomit, throw up, car, automobile. Antonym. Whereas synonyms are words with identical or similar meanings, antonyms are words with an opposite meaning, like long, short, big, little, fast, slow. Taxonomic relations. Another way of word senses can be related in taxonomically. A word or sense is a hyponym of another word or senses if the first is more specific, denoting a surplus of other. Meronym. Another common relation is meronym, the part whole relation. A leg is a part of a chair. A wheel is a part of car. We say that wheel is a meronym of car and car is a holonym of wheel. Structured polysemy. The senses of a word can also be related semantically, in which case we call the relationship between them structured polysemy.
Assalamu alaikum. My name is Saad bin Amr Sakin. The most commonly used resources for sense relations in English and many other languages is the SysNet lexical database. The database contains a set of lemmas and each one annotated with a set of senses. The WordNet 3 releases a huge number of nouns, verbs, adjectives, and adverbs. There are 8 senses for the noun and one of the adjectives, each of which has a gloss, a list of synonyms for the sense, and sometimes also uses examples. The set of near synonyms for a wordnet sense is called sysset. Syssets are an important primitive in WordNet. Glosses are properties of a sysset so that each sense included in sysset has same gloss and can express this concept. WordNet also labeled as sysset with a lexicographic category drawn from a symmetric field because these categories are often called supersense because they act as chorus symmetric categories. In some situation, we just need to disassemble a small number of words. In such lexical sample tasks, we have a small pre-selected set of targeted words and an inventory of sense for each word from some lexicon. A surprisingly strong baseline is simply to choose the most frequently sense for each word from the sense in a labeled corpus. A second historic cause one sense per discourse is based on a work who noticed that a word appearing multiple times in a text or discourse often appears with the same sense. This heuristic holds better for coarse grained sense and particularly when a word sense are unrelated, so is generally used as a baseline. Thank you.
Hello everyone, I am Tariq bin Shams. I will discuss the rest of the part of this chapter. Firstly, alternate WSD algorithm and tasks. Feature-based algorithm for WSD are extremely simple and function almost as well as contextual language model algorithms. SBM classified to choose the sense for each input word and with the following simple features on the surrounding words. Part of speech tag for a window, three words of each side, stopping at sentence boundaries collections. So, uh, co-allocation features of words or n-grams of lengths 1, 2, 3 at the particular location in a window of three words on each side. Weighted average of embeddings. The Lisk algorithm is the oldest and most powerful knowledge-based WSD method and is a useful baseline. Lisk is really a family of algorithms that choose the sense whose dictionary definition shares the most words with the target word's neighborhood. Word sense uh, disambiguation is a much more fine-grained evolution of word meaning than the context-free word. We can think of WSD as a kind of contextualized similarity task, since our goal is to be able to distinguish the meaning of a word like vase in one context from another context. Datasets other than same core have been used for all words WSD. One important direction is used to Wikipedia as a source of sense level data. When a concept is mentioned in Wikipedia article, the article text may contain an explicit link to the concept Wikipedia page, which is named by a unique identifier. Then secondly, using thesaurus. So, thesaurus have also been used to improve both static and contextual word embeddings. A word like expensive is often very similar is embedding cosine to its antonym like cheap. Antonym information from thesaurus can help solve the problem. There are two families of solution. The first requires retraining. We modify the embedding training in incorporate thesaurus relation like synonym, antonym, or super senses. This can be done by modifying the static embeddings loss function of word to vector. So at last, word sense induction. It is expensive and difficult to build large corpora in which each word is labeled for its word sense. For this reason, an unsupervised approach to sense disambiguation, often called word sense induction or WSI, is an important direction. In unsupervised approaches, we do not use human defined word senses. Instead, the set of senses of each word is created automatically from the instances of each word in the training set. A frequently used technique in language applications is known as agglomerative clustering. In this technique, each of the n training instance is initially assigned to its own cluster. New clusters are then formed in a bottom-up fashion by the successful merging of the two clusters that are most similar. So this chapter has covered a wide range of issues concerning the meaning associated with the lexical items. That's all my presentation.